Let's first prove that the existence of a saturating flow in G' implies the existence of a feasible flow in G. So what we're going to do is we're going to take a saturating flow F' in this graph G' that we constructed, and we're going to use that to construct the feasible flow F in the original flow network G. Now the construction is quite straightforward. Recall that the capacities in G' were the capacities in G shifted by the demand D. So we're going to let the flow in G be equal to the flow in G' plus the demand. So if we had zero flow in G', then we'll have the minimum flow possible in G, which is the demand D of E. And if we sent, say, 2 units of flow in G' along this edge E, then we'll send 2 plus the demand along the edge E in the graph G. Now there's 2 things we need to check. We need to check that F is a valid flow. So for all the internal vertices in this graph G, the flow in has to equal the flow out. And to be valid, we need that the flow along an edge is at most the capacity. And additionally, we need to check that F is a feasible flow. That means it satisfies all the demand constraints. Let's start with this second condition. Let's check that F is a feasible flow. Now F' is a flow. What does that mean for the flow along a particular edge E? It's got to be non-negative. So what does that imply about this flow F that we just constructed? Well, then the flow F along the edge E is at least D of E. Zero flow corresponds to D of E flow. And since the flow is non-negative, that means these flows F satisfy the demand constraints, so F is feasible. While we're at it, let's look at the capacity constraints, the upper bound on these flows. We know this flow is at most C' of E along the edge E. That implies that the flow F along this edge E is at most C' of E plus demand E. Recall C' of E was defined as C of E minus the demand along E. Therefore, this quantity equals the capacity along the edge in the original network G. So this flow F that we constructed satisfies the demand constraints and satisfies the capacity constraints. So all that remains is to check that the flow into every vertex equals the flow out.